Here are the latest adjustments. Okay, picture this. A software engineer confidently pushes some new code to fix a super laggy billing dashboard. They're absolutely certain they just nailed the problem. It's this great optimistic moment, but it's also a total trap. Why? Because they're solving a problem in a complete vacuum, totally disconnected from what's about to hit them next.
Right on cue, enter the database engineer. They immediately jump in and say, wait, look at the query profiling data. The bottleneck is obviously the database. Boom. Suddenly, there's a second, entirely different solution on the table. We've all been in this exact scenario, right? The friction is immediate. You've got the software engineer trying to fix the front end, the database engineer pointing at the back end, and absolutely nobody is aligned. Two people, two completely unaligned solutions. And then the rest of the team jumps into the fray. The product manager chimes in with, hey, let's just redesign the whole thing, which makes the support lead basically throw their hands up and go, wait, hold on. Are customers complaining about the speed or the layout? What follows is a 45-minute meeting of just total chaos. You've got four brilliant people who end up leaving the room with way more work to do, but literally none of it connects. And why does this happen? Because they don't have a shared view of the problem.
Well, welcome to this explainer. Today, we're going to see exactly how to untangle that kind of chaotic meeting by exploring a brilliant rescue tool known simply as the map. It's this incredibly powerful visual framework that locates exactly where everyone is in the problem-solving process. Okay, let's dive into this. Here is our path for today. First, we'll draw the map, and then we'll traverse its four quadrants: defining the problem, analyzing the cause, designing the solution, and finally, implementing and verifying. Section 1. Drawing the map. Let's build this problem-solving framework. To avoid just talking past each other, we have to set the stage. Picture a visual anchor. All it takes is two crossed lines. Cross them, and four distinct quadrants emerge. Now, what's really interesting about this is that when everyone can mentally see this map, the right conversation can finally start. But to actually use it, we kind of need to decode what these axes mean.
Let's break down those axes. The horizontal axis runs left to right, and it moves from the problem over to the solution. Basically, you're either trying to figure out what's wrong or you're working on what to do about it. Simple enough. Then, the vertical axis runs from bottom to top, moving from the concrete, like the measurable, observable reality, up to the conceptual, which is the world of ideas and reasoning that we use to make sense of that reality.
Quadrant 1, defining the problem. Here, we are firmly in the concrete and problem space. Think of it like standing in your kitchen and hearing a dripping tap. It's a highly concrete signal that something is wrong. Now, Q1 is governed by a dominant rule: make explicit. It's there to warn us against a really dangerous trap. Say someone tells you, hey, customer satisfaction is too low. Actually, scratch that. That's just a vague signal. It is not the problem. If you treat a signal directly as the problem and start acting on it, you can spend weeks, literally weeks, solving the wrong thing. You have to take that tangible worry and turn it into a precise description with absolutely zero unstated assumptions. You make things explicit by creating what we call a Q1 contract. Now, as you lock in these 7 components, everything from the current state all the way down to the scope, you have to pay extra close attention to your stakeholders. Seriously, a missed stakeholder is the #1 most common way problem definition fails. Why? Because the person you forgot to consult in Q1 is the exact person who's going to block your solution at the very end of the project. Guaranteed. This contract also helps you figure out the stakes, which is super important because it tells you when to just walk away. Consider this number: 6,300 euros. To put that into perspective, if a proposed solution returns 9,000 euros, but you only have a 70% certainty that it's going to work, well, your absolute maximum acceptable price to fix it is exactly that, 6,300 euros. Paying even a single cent more means you net zero expected gain.
Quadrant 2, analyzing the cause. Let's move to and see how this builds as we enter the conceptual and problem space. So now we shift upward from the concrete what to the conceptual why. We know the tap is dripping, but what's actually causing it? Q2 is governed by the rule to decompose. The absolute biggest mistake you can make here is jumping to conclusions without testing them. There's this wild anecdote about a physician who had a patient complaining of post-meal rib pain. She immediately assumed acid reflux and prescribed medication. Well, a week later, the patient was back in total agony with gallstones. Her initial hunch was completely plausible, but she totally failed to decompose the cause space and actually test her hypothesis. To avoid that exact trap, we have to cleanly distinguish between 3 different levels of causation. Let's break it down. A symptom is simply what you observe. Think of it like the fire. A contributor makes it worse or more likely. That's the dry wood. But the root cause, the actual root cause, is the condition whose removal prevents recurrence. It's the frayed wiring behind the wall. Confusing these three is a massive analysis error. You can't just sweep away the dry wood and claim you've solved the fire hazard, right?
Finding that frayed wire requires running what's called a diagnostic loop. You can use a few different shapes for this: the 5 whys, a fishbone diagram, systems thinking, or a binary search. But you have to remember one crucial thing. You must feed the loop facts. An opinion without actual measurements simply cannot be tested.
Quadrant 3, designing the solution. We're crossing over into the conceptual and solution space.
All right, once we have our validated root cause, we cross over to the right side of the map into Q3. The dominant rule here is create focus. Humans naturally show up to a problem with their favorite hammer. Let's take a broken washing machine. One person says, oh, just repair it. Another says, let's buy a cheap budget model. And a third person says, finally, let's get that smart washer I've been eyeing. See? They are all jumping straight to their preferred fixes. To create real focus, you have to force yourself to generate genuine alternatives. Like, hey, what about just using a laundromat for a while?
That brings us to this really great perspective on thinking outside the box. The goal is to generate 3 to 5 genuinely different options, not just tiny, minor variations of the same idea. And you do this for a really good reason, to avoid the dangerous compromise trap. Think about it like this. If one person wants to turn left to avoid a ravine, and another person wants to turn right, the compromise is driving straight ahead, right into the ravine. So no, don't blend incompatible solutions just to keep people happy. You need 3 to 5 genuinely different options. Quadrant 4, implementing and verifying. Welcome to the concrete and solution space.
Now we drop down to the bottom right quadrant. This is where the paper design finally meets the messy physical world, which is why Q4's dominant rule is evaluate. So the crucial point is, a plan is still just a plan until it actually works in reality. Implementation isn't just about crossing things off a task list, it's about verifying that the solution actually solved the exact problem you defined all the way back in Q1.
There are 2 massive failure modes waiting for you here. Drift is when you lose sight of the original goal and start optimizing things just for the sake of optimizing. Translation loss, on the other hand, is a gap between the design intent and what's actually built. Imagine a team installing rooftop solar panels to hit a 70% carbon reduction goal. 2 months in, the whole team is passionately arguing about tilt angles and inverter brands, and they've completely forgotten about the carbon goal. They executed all the tasks, sure, but the actual why never arrived. So when implementation inevitably stalls out, don't just push harder. Instead, use this 4-question obstacle decision tree to systematically step backward through the map. Ask yourself, do we still know what done means? If no, well, you're back in Q1. Are we solving the right cause? If no, back to Q2 you go. Does the design actually work? If no, you guessed it, back to Q3. You have to treat obstacles as diagnostic tools, not just as execution failures. And this brings everything full circle back to our dashboard team from the intro. When they plot their chaotic argument onto the map, they quickly realized the support lead was hanging out in Q1, the database guy was stuck in Q2, the PM was over in Q3, and the software engineer was totally jumping the gun in Q4. Once they could visually locate each other, the clash of personalities just vanished. It became a choice between options. They finally agreed on one problem definition, and they moved through the quadrants together as a team. Which leaves us with this final, really important thought. Problem solving is rarely about who is the smartest person in the room. It's almost entirely about being in the right quadrant at the exact right time together. So the next time a meeting completely derails and everyone is pulling their hair out, pause and ask yourself, are we actually arguing or are we just in different quadrants? Figure out where you are on the map and the path forward will pretty much draw itself.